Okay, let's get this going here. LCM, find the LCM of 12 and 18. Oof. Write the first 10 multiples of 12. Well, this is the long way of doing it. So I'll try to do it in all the ways that we've done it in the past. And I'm going to speak louder for those of you who can't hear me. 602. Alright, so 12 and 18. One way of doing this is 12 and 18. And it says write the 10 multiples. Well, I don't know if I'm going to do that. So let's go. 12, 24, 36, 48, 60, 72, 84, blah, blah, blah. 18, 36 plus 18 would be another 54, plus 18 would be 72. Okay, plus 18 would be 90. Well, right here we can stop. I know it says write the first 10, but I'm going to stop. I can see there are two numbers in common, 36 here, 36, and there's a 72 and 72. By definition, LCM, least common multiple. The common multiples so far are 36 and 72. Should be plenty more, but we want the smallest one, which is, in this case, 36. Okay? That's a little refresher on LCM. So, bottom one, choose one of these problems that have not been solved. Solve it together on your student page. Well, we don't have a student page, so, and I guess I'll do them all because I don't know which one you picked. So 30 and 50, and I'll take advantage and I'll do them in different ways. 30 and 50 would be 30, 60, 90, 120, and 150. And 50, 100, 150, there's your LCM right here. Okay, they'll probably meet again down the road, but we're not interested in those. Okay. 30 and 45, let's do it the other way. 30, 45. Okay, and we can do it this way. I know I've told you can use prime numbers, only to use prime numbers, and that was because I just wanted to get you to practice. But we can use other numbers too. Okay, it'll get you the same answer. So this one, I will just stick to prime numbers. 2 won't go into 45, so we can use. 3 works. So we got a 10 and a 15. Okay, then we'll do this again, and it's a 5, and that's a 2 and a 3. Right there we know that we can stop because there's no other numbers. I mean, no number will go into 2 and 3 besides 1, so there's no point to doing this. And LCM, when doing in this method, hopefully you remember, it's all these numbers multiplied. So you got 3 times 3, oops, and I forgot the 2. 2 times 3 times 3 times 5, which in this case can also be written as 2 times 3 squared times 5. Okay, just again, if they ask you to write it in exponential form, that's what you do. And if you multiply, you get, let's see, 3 squared is 9, and 9 times 10 would be 90. So the LCM is 90. Okay. And let's keep going, and I'll do 42 and 70. I'm not sure we can, well, let's do 42 and 70 this way. Okay. Hopefully, I'm not sure if I did this with you guys, but 42 is 2 and 21. 21 is 3 and 7, and we circle our primes, so we know we can stop. 70, you can pick 7 and 10. Prime, circle. 10 is 2 and 5. Okay. So one way of doing this is to list them. So 42 and 70, I'm going to write them like this. And 42 is 2 times 3 times 7. And 70 is 2 times 5 times 7. You can circle these two, okay? Because they're in common. You circle these two, they're in common. So these two, they're in common, you are going to write it once down here. And then everything else that's not common, you're going to write it once as well. Okay? So the LCM of 42 and 70 would be, let's see, 5 times 7, 35. 35 times 3 is 105, or 210. Okay? So we'll do it in several different ways. Okay, excuse me. That was my brother on the phone. FYI. Alright, so where are we? We did 42 and 70. Now we've got to do 96 and 144. So you are free to do whatever choice you want, okay, on the state test. I don't think they will tell you, hey, do it this way or that way. Actually, they might ask you to list the multiples. Okay, they might ask you to list the multiples. So 96 and 144. Well, if I had a choice and I had to find the, oops, this is GCF, I'm sorry. Ooh, I've been doing LCM for all the past problems. That's not good. Alright, so let me go back. I guess I have to go back. Oh, bummer. So the first problem was 12 and 18. That was LCM. I didn't read this. And there, I would have bombed the test right there. So GCF between 30 and 50. Okay, so GCF between 30 and 50. This is a different question. Okay, so for GCF 30 and 50, you're listing the factors. So one way of doing it is this way. 1 and 30. 2 and 15. You need to know your times table to be comfortable. 3 and 10. 4 doesn't go, 5 does, 5 and 6, 7 doesn't, 8 doesn't. So in 150, 150, 2 and 25, 3 no, 4 no, 5 yes, 5 and 10, 6, 7, 8 no. So greatest common factor, what do they share here? They share a 10, they share 2, and they share 1. Out of all the things that they share, the greatest one is 10. So the GCF is 10. Okay. So I'm actually doing all those again. 30 and 45, let's do it a different way when the screen stops shaking. Okay, 30 and 45, let's do it slide. That's slide method, that's what it's called. 30 and 45, think of a number that goes into 30 and 45, that would be 5. You could have picked 3. But I'm going to show you that it doesn't really matter at the end of the day. 30 would be 6, and that would be 9. Okay, do it again, because there is another number that goes into both, which is 3, and that gives us 2 and 3. Is there another number that goes into 2 and 3 as well besides 1? No, there isn't. So the GCF is these two numbers multiplied, which gives you 6. That's your slide method. Okay. What was that? 45 and 60. And we're going to do this via prime factorization. So 45 and 60 is 5 and 9. This is 3 and 3. Circle, circle, circle. 60, 5 and 12. Okay. It doesn't matter which two factors you pick. It will always end up the same. 3 and 4, 3 circles. 2 and 2. Okay. So if we're doing it this way, one way of doing it is to list them. So 45 is the same thing as 3 times 5, and do it in order. And 60 is the same thing as 2 times 3 times 5. What do they share? They share the 5s. They share 3. Is there anything else that they share? Because it's GCF, you're only going to bring it down what they share, which in this case is a 3 and a 5. So the GCF in this case is 15. Okay. What do we have? 42 and 70. 42 and 70. Let's do the slide method. Okay, I like that. Pick up a big number. 7 goes into both. That's 6, and it goes here 10 times. And another number goes as 6 and 10 is 2. It goes 3 times, and 5. We can stop right here. And I'm doing something wrong, because there's no way the GCF is 15. So 7 goes into 42 6 times, 7 goes into 70 10 times, 2 goes into 6 3 times, and 2 goes into 10 5 times. What am I doing wrong? 6, 7, 70 divided by 7 is 10, and then 10 divided by 2 is 5, and 6 divided by 2 is 3. What am I? Greatest common factor is not 15. Time out. Alright, nothing wrong. The only thing is me. So, GCF, and I forgot, the GCF are these two numbers. Okay? And 7 times 2 is 14. Okay? And we got one more. 96 and 144. Okay, you're free to choose whichever way you want. I wouldn't list the factors, like meaning go 196, 2, 48, that's way too long. Numbers are too big. So definitely slide method if it's big. And 96, I mean, a number that goes to both of them. Okay, and I said before, you don't really have to use prime numbers, okay? 12 goes into 96 8 times. 12 goes into 44 12 times. 12 goes into 8, no, it doesn't. So let's pick another number, 4. 4 goes into 8 2 times. 4 goes into 12 3 times. We're done. No other number goes into 2 and 3 besides 1. And the GCF of these two numbers multiply, which is 48. Okay, 48 goes into 96, and 48 goes into 144 3 times. Perfect. Okay, so that's your GCF, these two numbers multiply. So there, it's a little review. So where are we now? 75. I think we have to do 76. Okay, and again, I will do all of them. There are 10 girls and 14 boys, so let me write this down. 10 girls and 24 boys who want to participate in a trivia challenge. Each team must have the same number of girls and boys. What is the greatest number of teams that can enter? Okay, how many boys and girls will be on each team? Okay, hint. Hint there should have been the greatest number of teams. So you definitely want to do GCF. Okay, so GCF here, numbers are small enough that you can do it by listing if you want. Okay, think of a number that goes into 10, 24. And if you can't, you can do it this way. 1 and 10, 2 and 5, that's it. 1 and 24, 24 has a lot. 2 and 12, 3 and 8, 4 and 6. And it just happens that the GCF is 2. Okay, so, and you want to know how many teams you can make. Well, you can make 2 teams. Okay, so you can make Team A, let's call that Team A, and Team B. So, how many girls? Well, if you have 10 girls and you have 2 teams, it will be 5 girls here, 5 girls here. And boys, if you have 2 teams, it will be 12 boys here, 24 divided by 2, and 12 boys here. So each team will have 5 girls and 12 boys. Okay, and that's that for that question. The ski club members are preparing identical welcome kits for new skiers. They have 60 hand warmers and 48 foot warmers. 60 hand, 48 foot warmers. Okay, they want to make kits, so goodie bags. How many goodie bags can they make? And each goodie bag should have the same number of hand warmers and same number of foot warmers. So I would do a slide. Numbers are a little bit bigger. Okay, so I pick a number that goes into 60 and 48. You can use just primes. I know I told you at the beginning of the year to use primes. I just want you to get used to, but you don't have to. So 12 goes into 65 times, and here 4 times. You're done because no other number goes into 5 and 4. So 12 is the greatest number of kits that they make. Okay, so they'll have 12 kits, 12 goodie bags, call it what you want. So let's make this 12. 12 kits. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. 12 little goodie bags. So if I have 60 hand warmers, 60 divided by 12, it means that I'm going to have 5 hand warmers in this bag, in each bag. That goes on. I'm not going to write them all. And if I have 48 foot warmers and 12 goodie bags, it means 48 divided by 12 is 4. 4 foot warmers. So each goodie bag is going to have, each kit I should call, it's going to have 5 hand warmers and 4 foot warmers. So if you're a new ski member, you'll get a goodie bag that has those particular items. C. There are 435 representatives, 435 representatives, and 100 senators. Okay, how many identical groups with the same number of representatives? Okay, so you want to divide them in groups. How many identical groups? You want the largest group possible. Okay, you want to make teams, and each team has to have the same number of representatives and the same number of senators. Again, this is a big number, so when it's big, I would suggest a slide. and 5 goes into both. So 5 goes into 100. I know that for sure. It's 20. And this one, it's 8, 87. Okay. And let's see. 8 times 7, 35. Is there any number? 87 divided by 3. Yes, it works because it goes 29 times, but 3 doesn't go into 20. 4, 5. That's it. Huh? We can make a maximum of 5 groups. So if you had 135 senators, representatives, and 100 senators, and you want to make equal groups, maximum number of groups that you can make is 5, because that's your GCF. And each group, okay, would have 87 representatives. Okay, how did I get 87? Well, because if I have 435 representatives and there's 5 groups, 435 divided by 5 gives me 87. And senators, if I had 100 senators and 5 groups, I would put 20 senators in each group. 20 senators in each group. Okay. Alright, D, is the GCF a pair of numbers ever equal to one of the numbers? Yes. Okay. Explain, giving an example. Well, if you want to find the GCF between 5 and 10, okay, let's list 5. It's 1 and 5. And 10 would be 1, 10, 2, and 5. The GCF between 1 and 5 is 5, and 5 is one of the numbers in question. Okay? And let's lower this a little bit, please. Is the GCF... wait, stop, get away. Is the GCF of pair of numbers ever greater than both numbers? Ooh. Yes, of course. No, of course not. No. Okay, because your factors start, for 10, for example, the factors of 10 will be 1 and 10 is the highest number that it's going to go. Same with 5 or any other number. Okay, an example, let's pick big numbers, 48 and 56. Okay, GCF will never be bigger than any of these two numbers because you're looking at numbers that go into both numbers. That's what factors are. So 1 and 56, 1 and 48. So your GCF is going to be any number inside here. Okay, never going to be 49 or 57. Okay, it has to be within these two numbers. Okay, thinking LCM, by the way. And 77, this is LCM. LCM between 9 and 12. Now, if they asked that previous question, I would say yes. So 9 and 12, you can list them. You want the least common multiple. So you go 9, 18, 27, 36. So one way of doing this is by listing 12, 24, 36, and you can stop right here because you just met a multiple that's common and a smaller one, 36. Okay, 8 and 18 is the next one. Let's do that by slide, 8 and 18. You're doing a slide method. 2 goes into both numbers. 2 goes into 8 4 times. 2 go into 18 9 times. And in LCM, we take all 3 numbers and we multiply them. Okay, 9 times 4 is 36 and 2 is 72. So the LCM, the first number that both 8 and 18 can go into is 72. Okay. 4 and 30. I still like the slide method, so I'll keep doing slide. 4 and 30. 2 goes into 4 2 times. 2 goes into 15. 30 15 times. Nothing else goes into 2 and 15 besides 1, so we're done. And multiply all these two numbers. 15 times 2 is 30. Times 2 is 60. LCM is 60, meaning first number that 4 can go into and 30 can go into is 60. So that's your LCM. 12 and 30. I'll do this another way. I'll do this with prime factorization. 12 is 2 and 6, which means 2 and 3. Let's circle all our primes. 30 is 5 and 6. Okay, or any other factors that you may want to use is fine. And we're going to circle our primes, indicating that we're done. So 12 is 2 times 2 times 3. 30 is 2 times 3 times 5. Circle what's in common, so let me draw a line. This is in common, I'll bring it down. 3 is in common, I'll bring it down. And whatever's left over, you bring it down as well. Okay? Whatever is in common, you bring down once. So the 2 is a group of 2, so I bring that once. The 2 3s, I bring them as 1. And then left over, I bring them all. And if you multiply, you get 15 times 2 is, I don't know, 30 times 2 is 60. Okay, so LCM is 60. 20 and 50. Is there any other way I didn't do it? Well, let's keep it to a slide because that's, I think, the easiest. You can pick 10. Goes into 20 2 times. 10 goes into 50 5 times. No other number goes into 2 and 5 besides 1, so you're done. Multiply all three numbers, and you're going to get 100. So the LCM is 100. Okay. Next, choose. Okay, so I'm doing this. So hot dogs come in packages of 10. All right, hot dogs. You go to the supermarket, they come in packages of 10s. Do they really? Huh. And hot dog buns come in packages of 8. That's annoying. So if you're going to a picnic and you're bringing these, you want to make sure that you have one hot dog for one hot dog bun. So if you buy one package of each, obviously you're going to have more hot dogs than buns. So you have to find a way where the two would match. So one way of doing this is, you know what? I'll using a table. Why did I just say that? All right. So I buy another package. That's 10 more hot dogs. And this would be another 8. So that's 20 and 16. That doesn't work. So if I buy another package, it's 30 and 24. Sorry, another 8. That would be 30 and 24. That still doesn't work. If I buy another one, it would be 40. And here I would buy another one, which gives me 32. Okay, but then if I add one more here, it would be 40, which gives me a total of 40 on this side. So how many hot dogs do I have to buy? 4 packages. 1, 2, 3, 4. Hot dog buns. 1, 2, 3, 4, 5. Okay, so it would be 4 and 5. So, and let's use that using LCM. So LCM says, find the LCM of 8 and 10. Okay, and the LCM of 8 and 10, 8, 16, it keeps on going. They would meet at 40 here, 10, 20. The LCM between 8 and 10 is 40. Okay, so that means I need to buy 40 hot dogs, not hot dog packages or 40 hot dog bun packages, but 40 hot dogs. 40 hot dogs would be 5 packages, okay, and 40 buns would be 4 packages. Okay, that's why I have to be careful here. Okay. B, C, say 6 a.m. Okay, bus makes a stop at my street corner every 15 minutes. So bus, 15 minutes. Every 15 minutes. And also a cab comes every 12 minutes. When will they come at the same time at the corner? Well, LCM again. Okay, because it's something that's repeating, remember? Over and over and over. It's something that's repeating over and over and over. You want to find the least common multiple. So, least common multiple would be, let's see, if we list it, 15, 30, 45, 60. 12 would be 12, 24, 36, 48, 60. There you go. Every 60 minutes at that corner right there of your house, a bus and a cab would be there with me. Okay? And blah blah blah. 2 gears. 2 gears on the machine are aligned by marker on the center of one gear. The first gear has 24 teeth The second gear, I don't like this question by the way, that's 40 teeth. How many revolutions of the first gear are needed until the marks lined up again? So gears, can I don't even know how to draw gears. Okay, there's a gear, sort of. Okay. Okay, think of a gear like that, one of those things that rotates and has little teeth, square, rectangular teeth on the top. Okay, and there's another gear here, and obviously this one has more gears, more teeth. Wow, talk about ugly drawing. Okay, and they're rotating. This is rotating. This is also rotating. I guess that's what they're talking about. Okay, and eventually, at one point, they will meet and sort of fit with each other. So LCM, 2 goes in 24 12 times, and here 20 times. We can do this again. Pick a higher number. 4 goes into 12 3 times, and here 5 times. The LCM are all the numbers multiplied. So you get 2 times 4, which is 8. 8 times 3, which is 24. And 24 times 5 is 0, 2, 120. Okay. So what the answer to the question is, how many more revolutions? 120 revolutions. Is it right? 120. Yeah, I'm going to say 120 more revolutions until they meet again. Okay. And what was this? 176. 76. We're not doing 77, right? I think. And 78. And then we're doing 79. Am I correct or not correct? No idea. Okay. So, 79. Next, choose. Would you rather find all the factors of a number or find all the prime factors of a number? Why? Huh. Well, let's see. Let's pick a number. 24. Would you rather find all the factors of the number? All the factors of numbers would be 1, 24, 2, 12, 3, 8, 4, 6. That would be all the factors. Now, if the question said find only all the prime factors of this number, then it would be 2. And again, remember, you know what? Let me change numbers. All the prime factors would be of 36. Well, 1 is not a prime number, but 2 is a prime number. So 2 is a factor of 33. 3 is a prime. Does it go into 33? Yes, it does. 4 is not prime. 5 is not. 5 is prime. Doesn't go into 36. 6 is not prime. 7, 8, 9, 10, 11 is prime. Does it go in 36? No. 12, 13, 14, 13. No. 14, 15, 16, 17, 18, 19, 20, 21. It's a little painful, no? So you're much better off finding all the factors like this and then look at this, at the numbers that you have, and just circle all your prime numbers, 2 and 3. So to answer the question, I would much rather find all the factors of the number and then from that list pick out the prime factors. Okay? B, find the GCF of your original pairs of number. I have no idea what that is, so we're not going to do that. Hopefully you didn't go crazy on that. And then, is the product of your LCM and GCF less than, greater than, or equal to the product of your numbers? Okay, when you have a question like this, and they have no numbers, and it's just a question, take two. Take two numbers. Alright, so let's pick a number, 10 and 12. Okay, and I'm going to use the slide method. 10 and 12. The 2 goes 5 times, and here 6 times. Here's my GCF. So the GCF is 2. The LCM is 2 times 5 times 6, which in this case would be 60. So the question says, is the product of my LCM and GCF, so if I multiply 2 and 60, which is 120, is that going to be greater than or equal to the product of your numbers? And 10 times 12, which is the two numbers that we started with, is 120. Huh. I either got lucky, they just happen to be the same, 120. I did not know that. You know what? And just because I did not know that, I'm going to pick 2 more numbers. Let's pick easy numbers, 12 and 8. Instead of, and again, let me just do the slide. I want to see if that's a true statement. 12 and 8. Pick a number that goes into both. 4 goes into both, or you could start with 2. That's fine. 12, this is 3, and this is 2. My GCF is 4, which is this guy. My LCM is all the numbers multiplied, which in this case would be 2 times 3, which is 6, times 4 is 24. So again, back to the statement. Is the product of my GCF and LCM, which is 4 times 24, which gives me, let's see, 96. Okay, if I multiply 24 times 4 is 90. Is the product of my GCF and LCM the same as the product of the 2 numbers that we are talking about? 12 times 8, which is 96. Well, look at that. Huh. And it's equal. Okay, so I guess the trick here, not the trick, or the easier way to do this was to pick 2 easy numbers and actually work them out to see if the statement is true or false. Interesting. D. Glenn's favorite number is very special because it reminds him of the day his daughter Sarah was born. The factors of this number do not repeat and they're all prime numbers less than 10. What is Glenn's number? The factors of this number do not repeat and they're all prime numbers less than 12. What is Glenn's number? When was Sarah born? And are all prime numbers less than 12? Alright, let me pause this because I don't want to waste your time with this. Hang on a second. Alright, so prime numbers less than 12 would be 11, would be 9, no, 8, no, 7, yes, 6, no, 5, yes, 4, no, 3, yes, and 2. So the numbers do not repeat, and are all prime numbers less than 12. Then the factors of this number do not repeat. Two and 11 is 22, 5 and 7 is 35. Well, I'm going to say either 5 and 3, 2 and 7. It's either the 15th or the 14th. I'll get back to you on that one. Last page, find the GCF. Oh, okay, so you got 12 and 18. Remember we did this in class? Okay, here's 12 and 18, and you wanted to write it. We did, actually, some of you, I just did it in class, some of you I haven't seen it yet. So, 12 and 18, and you want to go back to this format. Okay. Alright, so pre-distributive factor. So you want to factor out. So the quick way, what number goes into 12 and 18? Well, the biggest number that goes in 12 and 18. 2 goes in 12 and 18. Let's say, is there any other number? 3 goes in 12? No. Yes, 3 goes in 18. So choices are the GCF between 12 and 18, by the way. Okay. Let's list 1 and 12, 2 and 6, 3 and 4, 1 and 18, 2 and 9, 3 and 6. Ooh, I'm sorry. So the greatest common factor is 6. And that's the number that's going to go out here. So now ask yourself, what 2 numbers will go in here? Well, 6 times what is 12? That would be 2. And 6 times what is 18? That's 3. You can always double check by using the distributive property. 6 times 2 is a 12, our first term here. And 6 times 3 is 18, our second term over here. Okay? 42 and 14. Again, we want to write an equivalent expression. Okay, so what number goes into 42 and 14, or what is a GCF of 42 and 14? In this case, it would be 7. All right, so ask yourself, what 7 times? Remember, we did this earlier in the year with Angry Birds. 7 times what will give you 42 here? Will be 6. And 7 times what number will give you 14? Will be 2. Okay, so they both are equivalent. And then we have 36 and 27. And okay, you find the GCF. You can do it whatever method you choose. Once you find it, I want you to put that number here. So 36 and 27, the LCM would be 9. It's the greatest number that can go into 36 and 27. So 9 times what's 36? Times 4. 9 times what's 27? Times 3. Okay, so 9 times parentheses 4 plus 3 is the same thing as 36 plus 27. And finally, last one, 16 plus 72. I think I should have done it this way because it's probably easier to see. Okay, biggest number that goes into 16 and 72. Let's see. 7, no, 6, 8. 8. 8 goes in 16 and 8 goes in 72. So I'm going to put the 8 outside. Now, 8 times what will give you 16? Times 2. And 8 times what will give you 72? Would be times 9. And that's that. It should be uploaded. It's 5:45. It's late. And, here is, and I have to write your, okay, so your message or your secret whatever, code, or this is what I want to know. Who called? Okay, earlier in the video somebody called and I told you who it was. Okay, that's it.